times k plus 1, okay, plus the nth, the next term after it, okay, which is 1 over k plus 1 times k plus 2. We have to show that that's equal to, well, this thing here on the k plus 1th term. So k plus 1, n is equal to k plus 1, would be k plus 1 over k plus 1 plus 1, which is k plus 2. So we need to show that the summation of this thing here, when we add on this k plus 1 term, actually comes to this particular value here. Okay? So let's try to do that. So how are we going to be able to do that? Well, let's go back to the thing that we've assumed to be true. Okay? So let's take what we've assumed to be true. So from our assumption, okay, so let's say from our assumption, right, we have, well, what do we have? We have that 1 over 1 times 2 plus 1 over 2 times 3 all the way through to plus 1 over k times k plus 1, okay? That must be equal to k, that must be equal to k over k plus 1, okay? We know that this, we've assumed this to be true, okay? So now let's add on the k plus 1th term to both sides, yeah? And just recall there, okay, that the k plus 1th term, okay, is the next term after this one here. Well, from the general form here, okay, it's 1 over n times n plus 1. So the one after it is going to be, well, when n is equal to k plus 1, it's going to be 1 over k plus 1. That's because n is k plus 1 times k plus 2, because k plus 1 gives us k plus 2 here. So this is the thing that we're going to actually add on. So let's add that on to both sides. So we're assuming this to be true. So when we add it on, we have 1 over 1 times 2 plus 1 over 2 times 3 plus all the way through to plus 1 over k times k plus 1 plus this term, this k plus 1 term, which is 1 over k plus 1 times k plus 2, must be equal to, well, this is true, so it's equal to k over k plus 1, and all I've done is I've added on this term on the left, yeah, okay, so we've assumed this to be true, and I've added on this term, so I need to add it on over here, okay? K plus 1 times k plus 2. Now what we'd like to do is we'd like to show that this thing here is equal to, well, what we need to show from step 3, we need to show that when we add on the k plus 1 term that we actually get this particular term here, okay, k plus 1 over k plus 2. And actually, I think you can probably see that this is actually going to happen nicely, yeah? Okay, so looking at the right-hand side here, this is equal to, well, we could have a common denominator here of k plus 1, okay, times k plus 2. K plus 1 into this goes k plus 2 times. K plus 2 times k gives us k times k plus 2, okay? Plus k plus 1 times k plus 2 divided into k plus 1 times k plus 2 goes once. So we have, it's going to be plus once times 1 gives us 1. So in this case here we end up with multiplying out the brackets. We have k squared plus 2k plus 1 as the numerator divided by k plus 1 times k plus 2. That's a quadratic, which is actually the same as, well, when you look at that, it's k plus 1 times k plus 1. Okay, because k plus 1 times k plus 1, actually, when we multiply out the brackets, we get this. And our denominator is the same. And you can see actually what's happening is that these two things are cancelling out, which gives us k plus 1 over k plus 2. So actually, okay, from our assumption, yeah, okay, that this is true, when we add on the next term to this assumption, what we actually get, okay, here, okay, is what we wanted to show, okay, is based off this particular thing here. So actually now what we know is this, is that, well, we now need to do the induction, is that we now know that this thing here is equal to this, okay. So we've shown this to be true for k plus 1. We know it's true for n is equal to 1. We now know it's true for n is equal to k plus 1, which means when n is 1, sorry, when we know it's true now for n is equal to, well, when k is 1, 1 plus 1 gives us 2. Okay, so it's now true for n is equal to 2, which means it's true for 2 plus 1, which is equal to 3, and so on and so forth. So it's true for all of the natural numbers. Okay. Okay guys, once again, this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and I hope that this video dealing with mathematical induction, I hope that it was in some way intuitive, and more importantly, I actually hope that was helpful for you, and thanks for watching. Okay, bye bye.